Hello and welcome back to the 4.3 notes. This is a section about absolute value equations and inequalities. And so we're going to go through first what absolute value means, okay? And so the absolute value is of a, denoted by these symbols here of a number is denoted to be the distance from that number from zero, okay? So let's take a look at what all this notation means. Okay, so when you see this number, okay, when you see a number inside of these like straight lines here, the rule of thumb is that it's always going to be positive. Okay, and we're going to talk about why that is. Okay, this is always, actually it makes it, let's write that, makes it positive. Okay. And so, so what I have over here, here's like the graphical approach. Let's say that we wanted to find the absolute value of -7. Okay, and so what I would do on a number line is I would locate -7 on a number line, and then I would also locate 0. Because remember what absolute value means. It means that it's defined to be the distance that number is from 0. So when I come over here, the distance between, -7 and 0, all right, this distance is going to be a distance of 7. And that's what it's asking you to do. Find the distance between -7 and 0. What's that distance, okay, which is 7. So rule of thumb, just always take whatever number is in here and make it positive, okay? And I could even go back and do, say, like +7, okay? What's the absolute value of +7? Then I find 7 over here, all right, and what's the distance between 7 and 0? And that would be a distance of 7, okay? So whatever is inside of there, make it positive. All right, so the next thing we're going to do is we're going to solve absolute value equations. We're going to solve these down here. But I want to revisit this example real quick as to how we would solve for this type of equation. So let's just say that if I take the absolute value of some number x, okay, so in here, up here, it was, you were just prompted to find the distance, okay, between those two. But now you have to sit here and you have to go, okay, if we write an equation and say the absolute value of some number is equal to 7, then what are those numbers, okay? And so x could be, remember we had one example here, where it's -7, okay? And then we had another example of one where we took the absolute value of 7, okay? And so if I take the absolute value of 7, -7 and 7, I'm going to get 7 as an answer, okay? So the values that could make this equation true would be -7 and 7. And so I get those two answers. All right, so I'm going to apply this concept over here on A, B, and C when I'm solving for x, okay? And so part A is a little bit, is pretty easy, okay? To solve this, what I'm going to do is x could equal both 8 and x could equal -8. All right, and sometimes we call that, we'll write it as x equals plus or minus 8, but for our purposes now, when we're solving these, I usually like to write out both of them, okay? And that's going to be my strategy, for the next few problems, okay? So let's do this. All right, let's go to part B. Now part B has this, okay? It's got the absolute value of 5x minus 2 plus 4 is equal to the number 7. Okay, so what I want to do is, we're solving this equation for x. The first thing I want to do is isolate the absolute value here, okay? So I'm going to go ahead and solve for that. I'm going to subtract 4 on both sides, okay? And then I'm going to get the absolute value of 5x minus 2 is equal to 7 minus 4, which is 3, okay? Now that I'm at this part, okay, this part is the same thing as this, all right? I have the absolute value of something equal to a number. Absolute value of something equal to a number. So when I'm solving this one, what I want to do is I want to get rid of the absolute value symbols. Okay, to do that, I take 5x minus 2 is equal to positive 3, and I do 5x minus 2 is equal to negative 3. All right? Now that's the same thing that we did up here, except for once we got rid of the absolute value symbol, we just had x already there. Okay, now we have two different equations, and so we have to solve both of them to get two answers. All right, so let's take a look at this. All right, so if I solve this one, okay, I'm going to add 2 to both sides. Add 2, and that's going to give me 5x is equal to 5. I'm going to divide by 5 here, divide by 5, so I get that x is equal to 1. All right, and then here I want to add 2 to both sides, same thing, okay? And so then I get that 5x is equal to negative 1. All right, when I solve for x, I'm going to divide everything by 5 and by 5. So then I get that x is equal to negative 1/5, okay? And that's it. Okay, so those are my two answers. Now, let's take a look at part C, okay? And part C has this. We already have an isolated absolute value, but we have it equal to a negative number. Now, there's a problem here, okay? Remember that everything that's inside of here is going to be positive, okay? Is positive, okay? But then, when you set that equal to a negative number, that doesn't make sense. So the conclusion that you can draw is that there are no solutions to this. Okay? So, and that's the reason, is that this must always be positive. This part of the equal sign, okay, the absolute value, remember, that makes anything positive, all right? You can't set that equal to a negative number, okay? There's no way that this would work, all right? So what I want to go back through, because, you know, some of this is just kind of confusing. What I want to do is this. I'm going to go back through each of these problems. I'm going to show you a quick graph of each of these, and then what we're going to do is analyze that and how we get, you know, the answers that we get. All right. So give me a second, put those on, and we'll talk about them. All right, so I put the graphs on. Let's go ahead and zoom in on the first one in part A and talk about it. Okay, and so what I've done here is I've taken this left side of the equation and I did y equals the absolute value of x. And what that does is it gives me a, you know, the graph of y equals the absolute value of x, okay? Over here, y equals 8 is the horizontal line here, and I got that number from here. So when I take one side of the equal sign, okay, set it equal to the other, then, you know, you can solve and check your answers. Okay, so remember how I got x equals 8 and negative 8? If I look here, this x value is negative 8. This x value is positive 8. And that's why we get two solutions. So if you remember when we did systems of equations, how certain graphs would intersect twice, or, you know, just once, these, when, you know, graphs start to curve and move in different directions, you can have more than one intersection, and we can find that algebraically. Okay, so let's look at the other one here just real quick. I put y equals absolute value of 5x minus 2. This part here, I made sure that I had this as one side of the equal sign, and then the 3 as the other. You still get the same thing, but it's a little bit easier to see. And so here, you know, you got x equals 1 and x equals negative 0.1/5, which is negative 0.2. And 1 we got here as 1. Okay, now on the last one, I want to talk about that because, you know, we didn't get any solutions. So remember how what the absolute value thing does. It takes all these points here, you plug anything in for x, and the y value is going to be positive. Notice how all the y values are above the x-axis here, okay? Now we're looking for the intersection of this graph and this graph. Now when y equals negative 3, that value is completely below this graph here, which is why we have no solutions, okay? So I wanted you guys to see that and see this thing graphically, because when I just do it on, you know, the paper, you know, you're just kind of like, oh, I'm just doing this for no reason, okay? There is a way to check this to see if you are correct, okay? So now, let's take a look at this. Let's take that same graphical approach and let's look at these values here, Okay, absolute value of x is less than 2, and then the absolute value of x is greater than 2. So I'm going to graph both of these, and we're going to take a look at this. Okay, so now that this is graphed, I want you guys to see that I have the graph y equals absolute value of x graphed on one side, and then I have y equals 2 graphed here. Okay, and we're comparing whether the absolute value is going to be less than or what happens when it's going to be greater than. Okay, so when we're looking for our answers, let's just think about this. When I plug in a value for x, okay, and it takes the absolute value of it, when are these values less than 2? And when I'm talking about this 2, I'm really talking about the y value, y equals 2. Okay, and I'm wondering, okay, for this problem here, okay, let me color code this. All right, for this problem here, absolute value of x is greater than or is less than 2. That occurs here. Okay? Those are the points on the graph that I can look at that when I plug in an x value, it's going to be less than 2. Now I'm wondering, where does this occur on the number line? This happens between -2 and +2. Okay? And I get those numbers here and here. All right? And those are the values when we're going to be less than 2. Okay? And if I wanted to talk about those values, I would say, well, those values for this graph are going to be in between -2 and 2. All right? And so I would go from this over to my solution, which is -2 is less than x is less than 2. Okay? This is my solution to the inequality. All right? Now, let's talk about the other one. Let's talk about when the absolute value of x is greater than 2. Okay? Now this happens when it's above the line, okay, when it's above 2, all right? And so if I wanted to, you know, take a look at those, all right, to see that, then, you know, I'd say, okay, where does that happen? Okay, and that's going to happen when x is less than -2, but and also when x is greater than 2. Okay, and so I'm going to write that. And so I'm going to write that my solution is x is less than -2 and, or should I say, because it's a union of values, then I would say that this is also x is greater than 2. Okay, and that's when those happen. So when you're asking these questions, all right, you're looking at for the y values. Okay, where are the y values positive or above this line of 2 or below this line of 2, and then where does that happen on the x-axis? And that's what this part is answering. Okay, and so you know, this is my solution set. Okay. And so the one way that I kind of like remember this is that if the absolute value is less than 2, then I just take the opposite of 2 and put another symbol here and make this inequality. Okay. If it's the other way around, then I make sure that I do one that says whatever the absolute value was is greater than the positive number. Okay. And then I make one where I switch the inequality and then make that number the opposite. So, okay. Okay, so we already kind of did that part. All right, so let's go down to solving these absolute value inequalities. Okay, and this part here kind of means the same thing that we just did here. Okay, if the absolute value is less than p, then we write it like this. If the absolute value is greater than p, we write it like this. And then if we have, you know, is equal to, then we put those in as needed. So let's go ahead and let's solve the following inequalities and write our answers in interval notation. So what I want to do is this, okay? You know, the first thing I want to do is understand that this is absolute value of x is less than or equal to 4. So to solve this, to get rid of my absolute value symbol, I do x plus 2 is less than or equal to 4. Okay, keep that part, but then over here make this less than or equal to, and then put a -4 down over here. All right, and then I'm just going to solve. So I'm not going to add 2, I'm going to subtract 2 from both sides, or from all the sides, rather. Okay, so if you do it to the inside, do it to the outside ones as well. Okay, and then you're left with the x is greater than or equal to, and it's less than or equal to. Okay, so then negative 4 minus 2 is going to give me negative 6. And then 4 minus 2 is going to give me positive 2. So when I graph this, okay, here's 0, here's 2, here's negative 6, okay, brackets, shade in the middle, okay, and that's going to help me write it in interval notation, and I'm going to write this as bracket negative 6, comma 2, okay, and those are the answers that would satisfy this inequality. All right, let's look for the next one real quick. Okay, and so if I were to have a number, I want to isolate my absolute value first. So I'm going to divide everything by 4 here. Okay, you can't distribute that. So 4 divided by 4 goes away, and then you're left with the absolute value of 4 minus 5x is greater than 16 divided by 4, which is 4. Okay, now remember, to solve this, we've got to create two inequalities. So I'm going to do 4 minus 5x is greater than 4. Or I'm going to do 4 minus 5x is less than negative 4. Okay, remember, I keep the same sign here. Okay, this doesn't change, but then on the next one, I flip my inequality symbol and make this one negative. Okay, so now let's go ahead and solve this. So let's solve it for x. I'm going to subtract by 4 on both sides. Okay, and so I kind of get this unique problem here. And that's that you get negative 5x is greater than 0. Now, when I continue to solve this, I'm going to divide both sides by negative 5. Now, the act of dividing this by negative 5 is going to switch my inequality, and we're going to get that x is going to be less than 0. Okay? And that's my first inequality. Now, and I'm still just doing 0 divided by negative 5. It's not going to change this sign, but we got to make sure that we go x is less than 0. We've got to change that if we divide by negative. Okay, over here, let's do the same thing. Let's subtract 4 from both sides, all right? Then I get negative 5x is less than negative 8. Now I'm going to divide everything by negative 5, negative 5. These divide out. I'm going to get x is greater than positive 8/5. Okay, and so, in one of them you're less than 0. On the other one, x is greater than 8/5. Okay, so let's think of this in interval notation, or let's graph it first. I prefer to graph it. All right, so here's 0, here's 8/5. Okay, now what I've got is that x is less than 0, so I'm going to shade this way. Okay, that we're smaller than 0, and x is larger than 8/5, so I'm going to shade this way. Okay, and so then, in interval notation, I would write this as negative infinity to 0, union with 8/5, comma, infinity. Okay, sorry, I'm a little getting bunched up over here, okay, but that's my answer. So, okay, now let's talk about question C, which is kind of interesting. So whenever I have an absolute value symbol, okay, I'm always going to say that this will always be positive, okay? And I'm dealing with a negative number over here. Anytime that you're dealing with a negative number with an absolute value and like an equal sign or an inequality sign here, you always need to kind of like think back and look at what's going on. All right, so here's what I've got. So this is negative. Okay, now I have something that will always be positive, and it's going to be smaller than a negative number. Okay, that's a contradiction. That doesn't make sense. Okay, so here's what I've got. There are no solutions to this problem, all right? Because in this case, you've got an absolute value symbol. It's always going to be positive. It's never going to be, a positive number is never going to be smaller than a negative number, okay? So this is not true, okay? You can't make any claim here, and there are just no solutions, all right? Now let's take a look at D. All right. Now, what I have here is I have an absolute value problem, and that's going to be greater than 0. Okay. Now, here's the thing. When something must be positive, okay, this must be positive, then I know that it's larger than 0, which is what we have here, okay? And that's what's happening, okay? Since we are larger than 0, okay, this part is 0, this part is always going to be larger than itself, than 0, okay? So what I want to say here is my solution set is all real numbers. Okay, except for one number technically, which is 0. And let's take a look at the graph on this. Okay, so if we look at the graph on this, what I notice is that here's my graph of 3, absolute value of 3 minus x, and there is a point when you plug this in and you do get 0, okay? So you are not actually less than 0, so, or I'm sorry, greater than 0. So the actual solution set that we want to choose is, the fact that we are above the x-axis for all of these points except at 3. So our actual solution set here is going to be negative infinity to 3, union with from 3 to positive infinity. Oops. Okay, and that's that. All right, so just kind of some interesting things to say about that. And so, if you wanted to go back through and solve these and look at the graph of this, you'll see a similar type of thing. And actually, let's look at the graph of this one real quick, and then we'll stop the video. Okay, so remember on this one, when I look at the graph, here's the absolute value of x minus 2, this graph here in green, okay, and then negative 5 is down here. So the question is, when is this graph going to be below negative 5? And it's not. Okay, this is always positive, this is always negative. Okay, this will never drop below this line here, and that's why there are no solutions. Okay, so that's all I've got. Hope you guys enjoyed this video. I know it's kind of a lot of information, but do your best, and we'll see you in a bit. Thanks. Bye.